Okay, so we're going to do this trig integral, and we're going to look at several different cases. The main thing is to recognize the type. And so when you have a product of sine and cosine, generally, if the degree of either one of these is, if you have an odd one, if one of them is odd, then you're a happy camper, because that makes it a lot easier. If one of them is odd, then what you do is you break it up so for example, in this one, sine is odd, but if cosine was odd, you would do the same thing. You're going to grab one of the sines and just kind of put it off to the side, and what's left over is just sine squared and then cosine squared d theta. So why would you want to do that? Well, because then you can use your trig identity. You can convert this sine squared into 1 minus cosine squared. And so then, if you look at this, you would get 1 minus cosine squared theta cosine squared. And so what happens here is that this sine of theta, if you now let u equal to cosine, so you would have this one is u and this one is u. Notice that du is going to equal to negative sine, which is pretty much right here, right? The only thing we have to do is add a multiply by a -1 right here, and then we'll take out a negative on the outside. But this right here is pretty much du. And so this is a perfect candidate for integration by substitution. What we have then is negative the integral of 1 minus u squared times u squared du. And at this point, this one is pretty easy. We distribute. We would get u squared minus u to the 4th du. And so this is minus u cubed over 3 minus u to the 5th over 5 plus c. And so then if I just go back to the original value of what u was, cosine, so this is going to be minus cosine cubed theta over 3. Plus, right? Plus, good thing I caught that one, cosine theta over 5 plus c. And that's it. Now, if one of them is, if they're both even, then you can't use this, but it's just a little bit more work. But we'll do one of those later. Okay, so here we have cosine to the 4th y dy. And let's remember our reduction formula, which you should have memorized. I'll write it over here on the side. Okay, so what we're going to do, we're going to use it once only, just to get the degree down a little bit, and then we'll do the rest with identities. So basically what we end up with, so if I use this, notice this 4, n is equal to 4 in this case. So this is going to equal to 1 over 4 cosine cubed y sine of y plus, and then n minus 1, that's going to be 3 over n, which is 4, times the integral of cosine squared y dy. Okay, so now we reduce, that's why it's called a reduction formula. We reduce the degree, and then to find the integral of cosine squared, what we need then is a identity, and that is that cosine squared y is equal to 1/2 1 plus cosine of 2y. Okay, so if you replace that right here, then what you end up with is 1/4 cosine cubed y sine of y plus, so this is going to be 3/4 times 1/2, that's going to be 3/8. Okay, and then here, why don't we just instead of rewriting the whole thing, why don't I just put right here, this is going to be the integral of this. The 1/2, I already built it in right here, but the antiderivative of 1 is just going to be y. And then the antiderivative of cosine of 2y, that's simply a positive sine of 2y over 2. And remember, the 2 on the bottom comes from the antiderivative of cosine of 2y, because of the chain rule. If you were getting the derivative of sine of 2y, you would multiply. So that's why when you're getting the antiderivative, you're going to divide. And that's pretty much it.